afternoon, everyone. Today we will continue with the 8th session for this special webinar series that has been organized by the UNIDO Directorate of Digitalization, Technology and Agribusiness, and particularly with the focus on mainstreaming for industrial revolution technologies in specific sectors, more in particular on what are the operations, mechanisms, and the relevance for small and medium-sized enterprises in the context of a specific set of industries. I will share my screen to introduce the panelists and the agenda for this one. So for this webinar that is entitled Smart Industrial Energy and Current Digitalization Trends, I will be the moderator. My name is Alejandro Rivera Rojas, and I am the Executive Officer of the UNIDO DTA Directorate. We want to focus specifically on the convergence of 4IR digital technologies and how they can support rule-based energy management and reporting systems by digitally controlling the process of energy production and consumption. In combination, they also can enable the automation of data analysis and the decision making and reduce the average energy cost while enhancing efficiency levels. This webinar will look into these prospects for supporting SDG 7, SDG 9, and SDG 13, addressing these pressing challenges like intermittency of supply and their suitability to adopt it on their different socioeconomic contexts. For this occasion, we have invited the following panelists. We will have with us Mr. René Hoffman, Head of Research Group Industrial Energy System, also coordinator of the doctoral school Smart Industrial Concept from the Vienna Technical University. Next to his current role at the university, René is the principal scientist at the Austrian Institute of Technology in the Center for Energy. His current main research focusing on design and operational optimization of energy systems and digitalization aspects, particularly digital twins for complex industrial and energy production systems. We will have also Mr. Sean Radka. He is Associate Program Officer at the International Renewable Energy Agency, IRENA. His background lies at the confluence of international relations and innovative energy technologies, and he holds a master in international relations from the Korea University. He is also graduate from the School of International Studies, and his scope of work will include the emerging role of power sector digitalization, and particularly distributed ledger technology as part of the ongoing sustainable energy transformation. We will have also Miriam Bonilla Garcia. She's the Chief Commercial Officer of Edibon. Edibon is a well-known Spanish company designing and manufacturing engineering and technical teaching equipment at the highest level and quality in most engineering areas. Miriam has more than 20 years of experience and practical capability for full designing and managing of labs for technical teaching and training. Mr. Naoki Tori is our colleague here in UNIDO. Is industrial development expert at the Climate Technology and Innovation Division in the Department of Energy of UNIDO. Mr. Naoki holds a Master in Science in Environment and Development from the University of Edinburgh. Within his current role, he's managing projects facilitating renewable energy productions uptake of energy efficiency measures, as well as clean tech innovation in Asia and Africa. Our external panelists will be providing further insights on the potential and opportunities of digital technologies in alignment with the UNIDO Directorate Strategy outcomes, while our colleague, Mr. Naoki, will provide insights of the work that UNIDO is doing to support the production of smart industrial energy in specific projects. We will have a round of initial presentations for all the panelists, and later on, we will be starting with a set of questions for each of them. For all attendees to this webinar, we would like to encourage you to raise your questions by using the questions and answer function. Yeah. Also, for your information, today we are recording this session, and we will make the recording available as with the others through our Knowledge Hub platform. We will also share the panelists' presentations, yeah, for your information. So, having said this, I will now stop sharing my screen, and I will provide now the floor to our first speaker, Mr. René Hoffmann. The floor is yours.
Ladies and gentlemen, good afternoon. In the next few minutes, I will show my presentation on the Energy 4.0 digitalization aspect, especially innovative optimization methods and the use in the direction of digital twinning. Well, I give you first a short outline after a short motivation about the connection of the sustainable development with Energy 4.0. I will focus on the challenging task, especially of the data and information, and also use the view on the services. And therefore, I will show you some application examples, especially for the optimization of industrial processes right into the direction of the digital twinning. What we need, therefore, is a cooperation. And after this, I will summarize for exploit the digitalization to make the industry more sustainable. So let me start with a short motivation. In Austria, we have round about 314 terawatt hours energy are consumed every year. And this energy is in industry round about 30%. So to reach the goals, of the Paris Agreement, we need to reduce the CO2 emissions by around about 40% by 2030 and even by 80% by 2050. And therefore, we have Energy 4.0 as a possibility that shows the path forward. Because as we already heard, we have the SDGs formulated here. Also, the number 7, 9, and number 13 is named. So Energy 4.0 means to utilize untapped potential of energy systems through the massive employment of digital technologies in this case. And it allows us to increase the share of renewable energy and reduce the energy consumption of industrial processes. So this makes industrial processes more sustainable and even has the potential to decrease cost at the same time. Well, the next is how to connect the development and the evolution of the information and communication technologies, also called ICT, has brought a radical transformation in the world where we're living in. And the powerful autonomous microcomputers like embedded systems are increasingly being wirelessly connected and with each other and using the possibility of the Internet of Things and the services. So this has resulted in the convergence of the physical world on one hand side and the virtual world, which is the cyberspace on the other side, so-called the cyber-physical systems, and therefrom it emerges up the Energy 4.0, which is based on the CPS and other challenging enabling technologies in this case. So the challenging is if you have an industrial plant, so you have to answer a lot of questions because you have to look to minimize costs, the product quality, energy supply, decarbonization, and so on. Also provide flexibility. So let's have as a look in the industrial plant. So we need to integrate renewables and we have to use the raw materials, which can also be seen as a storage capacity in terms of industrial energy hub. And we have to provide certain electricity and process demand and also the district heating part. So we need to have the optimization in the terms of the design and operational phase to reduce energy and costs. In more detail, if we have a look on the industrial process, on one hand side the production, on the other hand side the electricity market, one overall goal is the realization of digital twin possibilities. So using a real-time and historical data based on sensors and key performance parameters to instantiate the digital twin, in particular to represent those relevant parameters in the model, and then let them work bidirectional in real-time application. So this makes it possible to analyze and optimize not only, as shown here, the steam turbine, but also the production plan and also the energy supply systems. And this knowledge can be used later on for the optimized representation of the key parameters. So one application of this could be because the industry is not working in the manufacturing process itself, so it needs a connection to the local energy supply, and also this needs a connection further onto the grid. So we have a lot of interconnections. We need a lot of methods, different methods to handle those aspects in a perspective on optimization. So to have the big data, because we need data for information of this optimization, the left graph shows you the describing system, the representation, which is the ontology is based on the plant design, on the control design, and further on also on the model design. And then we have the runtime system, which produces a lot of data. So we have data mining, we have data analytics, and then we have to have the model tuning and the model transformation. This gives you the perspective to create from big data, smart data. And this perspective is really necessary because from those data approach, in summary, what it does is to take the industrial plant for the possibility for an efficiency increase and the cost reduction. So first, we have the uniform data, as already mentioned. Secondly, we have the models which have to be created. And thirdly, we have the digitalization tools in an operation optimization as we need them. So if several of these digitalization tools are combined, the digital twin could be emerged, which combines the potential of these digitalization tools. And this can save costs, maximize profits, and save energy. So, but now the questions arise, what is this, that this, I would say, tool is not already being used in every industry today? So what are the problems and what are the challenges and what are the needs therefore? And how is it possible to get them in industry? And I think one part is the cooperation in this phase, because this Let's Works method development together with industry. I will show you in the next two slides cooperations where I'm involved, especially in the IEA phase, in the technology collaboration program of the industrial energy related technologies and systems. And there is an annex, especially in the digitalization and AI. And here we are working international together. So this annex is led by Canada. And we have to create an international network for information infrastructure with stakeholders, and also facilitate of joint development of new knowledge and expertise, especially in the digitalization phase. And to support and accelerate the development of digitalization and practices, especially focused for the reduction of GHG emissions within the energy intensive process industry. Nationally wise, we are involved in the we have developed this white paper, and with the funding support of the Climate Energy Fund on the digitalization in industry as an Austrian perspective. You can find a link where you can have a look therein. So the next project I will emerge is the cooperation doctoral schools, what I'm leading. So this rests on those four pillars, as you can see. The left-hand side, the colored ones are here. So this is the data handling, the design, the operational optimization, and also the interconnection to the sector coupling effects. So therefore, we learn a lot how to design and operate plants with using those new innovative methods. So to summarize, my contribution is to exploit the digitalization to make use for more sustainability, because digital technologies offer a huge potential to improve industrial processes. We can see it in the macro level, which means we have the optimization phase. We can see also in the micro level, which means more narrowed down to the process side, in the part of a digital twinning technology of the bidirectionality working together, fully autonomous systems. And then we have what we need, therefore, is the collaboration of the research and the industry. I think this is the key factor, the driving. To integrate renewables into the existing sources, into the existing systems, also to increase efficiency and flexibility of this existing systems, and to advance climate goals. So I thank you very much for your interest, and hand over to.
Thank you. Thank you very much, René, for this very nice presentation, very informative one, particularly with explaining on the development of digitalization and energy 4.0, the challenges, particularly for the application in industry. This is, I think, very well taken by my colleagues here attending to this webinar, and particularly on the focus on data and the significance for digital twinning and artificial intelligence uses. Thank you very much. We will continue with the next speaker, Mr. Sean Raka. The floor is yours.
Thank you very much. Let me just get my slides showing here. So thank you, first of all, for this invitation to speak. I note our two Director Generals at UNIDO and IRENA, the International Renewable Energy Agency, signed a declaration to collaborate on SDG 7 last year at the Secretary General's Climate Action Summit in New York. So within that context, I look forward to our continuing collaboration, and thank you, Alejandro, for the invitation to speak today. It's much appreciated. So everything I'll mention today basically can be found on our website, mainly in our Innovation Landscape Report, the various sub-reports that discuss these digital technologies like IoT, AI, and distributed ledger technologies such as blockchain. So I'll keep it quite high level and use this as an opportunity to sort of show the UNIDO colleagues what IRENA can sort of help with to inform your work. And if you ever need anything from us, feel free to reach out to me. I'll leave my email on the last slide. We can provide data, figures, or information from reports and things like that. So this will just give a bit of a flavor of what we can sort of offer to inform your work on these topics. So just quickly, an overview of today's presentation. As Professor Hoffman showed, industry, energy use, and emissions are quite substantial. So what we did at IRENA is that we mapped this out globally through 2050. And we found that 7 specific industry and transport sectors will account for 38% of energy and process emissions and 43% of energy use by 2050. And I'll talk a bit about these specific industry and transport sectors. But essentially, I'll talk about industry for that reason, how to sort of mitigate the emissions through electrification as one option, what that does to the power sector, increased complexity, and basically how to manage that complexity with these new digital tools. And I'll use a few examples that sort of stray a bit from the agenda and go into a bit of the blockchain side in the developing world, if that's okay. So these are the industry and transport options I was mentioning. Basically, we have iron and steel, cement, chemicals and petrochemicals, and aluminum on the industry side. And in terms of commercial transport, we have road freight, aviation, shipping. We did not include passenger transport in this because we feel battery electric vehicles will not be a problem by 2050. It's more how we generate the electricity that goes into those batteries. But as you can see, the main point to take from this is that 45% of industry mitigation options will come from renewables, and 64% of transport mitigation options will come from renewables. And among those, direct electrification will play a major role at 20% in industry and 19% in transport. So with that, I'll talk a bit more about the electrification in that sense. So why are we talking about renewables? Basically, it's the economics. Over the past decade, we've seen dramatic decreases in costs, which makes it cost efficient. So the barriers that we see today a lot are on the policy side and regulation side. And the ability to sort of raise the funds for these upfront capital costs in the developing world to actually install these renewables. And then again, managing the sort of variability when it comes to solar and wind, but we can do that now more and more with digital tools. So with that, I'll continue. So the power system transition is being propelled by three trends as we see it: electrification, decentralization, and digitalization. Among the digital tools, we talk about faster response being a benefit, a better management of assets, connecting devices, collecting data, as well as increased monitor and control. So one thing we hear a lot from our member states is that these technologies are sort of disruptions, and they want to know about that, which I'm sure you do as well at UNIDO. But we sort of see it in the opposite way, that we see this increasing complexity, the decentralization, the decarbonization, the electrification. Those are the real disruptions, and the tools to sort of manage the disruptions are what we are seeing here in terms of, you know, AI, IoT, blockchain, and others. So increased power sector complexity requires a combination of these digital innovations. We see them really as a basket of tools where they work in tandem. I mentioned transport before. We see, I think, 5 million battery electric vehicles. Now, by 2030, that's going to be 150 to 250 million, depending on the source, but we think it's probably on the higher end of that. And with something like smart charging, for example, not only can these batteries be an asset, but these electric vehicles will sort of do the opposite of what a lot of people think in terms of, you know, not adding complexity to the grid, but they can really be batteries on wheels, which allow you to sort of increase the share of wind and solar in your grid by effectively managing these peak loads with smart tools and with the storage that can be flexible. Among these three digital technologies, I wanted to briefly discuss AI and one specific use case with data centers that we see, because with all this influx in data, we see increasing demand for data centers. But despite the concerns raised surrounding the growth of data centers and the electricity required to power them, we found a new study of data centers globally found that while data computing jumped sixfold over the past 10 years, energy consumption only rose 6%. And that's largely due to digital tools such as AI. And one example is Google's DeepMind AI, which has been seen to decrease power demand for cooling by 40% at data centers. So one thing that we really need to make sure happens with this increase in data center usage is that they rely on renewables. One thing we're seeing in the US is that US tech really likes renewables, mainly because of the economics, but also because of the consumer sentiment. So one thing that we see there, though, is that they have the money to invest and take care of the upfront capital costs, which can be a major hurdle. So where does that leave us in the developing world, and where should our work focus as intergovernmental organizations? So I wanted to take one example on this. It's not so much about AI or industry, but it sort of has to do with overcoming the problem with the availability of capital, specifically in this small scale space where we see 1 kilowatt to 5 megawatt, where it's quite difficult to attain financing. And I think this aligns very well with our goal with achieving SDG 7, and I think you would agree on that. So one specific example on this from South Africa is Sun Exchange. We had them at our Innovation Week a few years ago, and what they've been doing is, by using blockchain, they've been able to sort of access financing from around the world, whereby people can invest using Bitcoin. And what happens is they are able to fully fund projects, and those on the ground, whether they be schools or small businesses or apartment buildings, don't have to pay the upfront capital costs, but then they go on a 20-year lease for this electricity, which is cheaper than it would be from the grid. And also, not only is it sustainable, but it's more reliable, because as we know, there's a lot of load shedding in South Africa, and this leads to a lot of backup diesel generation, which is quite poor for the local air quality. So this has a number of sort of synergies and benefits. And this is just one very interesting, sorry, there's a police siren going by, but this is just one very interesting example. And we see a lot of interesting examples using distributed ledger technology, especially with renewable energy credits as well, which allows producers from around the world on the small scale to really, you know, get some funding back from their generation. And I see I'm right at 8 minutes, so I'll jump to the very last slide and just reiterate that if you have any questions at all, please feel free to reach out to me via email. I know this was a very quick, high-level overview, but basically all of this information is available on our website in our reports in depth, with examples from the developed and developing world for all of these different technologies. And we're happy to continue to work together with UNIDO, just feel free to reach out anytime. Thank you very much once again for the invitation.
Thank you very much, Sean, for this very informative presentation, particularly for sharing all these figures on the principles CO2 emissions emitters per sector. I think my colleagues have enjoyed a lot on the explanations on the IT, artificial intelligence and blockchain uses to optimize energy efficiency. Particularly, I think it's very nice that you talk about the challenge that the use of these digital technologies can represent versus the energy consumption and the solution you are providing for using more energy, renewable energies. Thank you very much. Continue with the next panelist. Miriam, the floor is yours.
Thank you so much, Alejandro and UNIDO, for the invitation. It's been an honor to me. Let me clarify that I'm coming from the training sector, from the educational sector. Reboot is a Spanish company that we are producing lab equipment. We have been 40 years already producing equipment for the laboratories. We like to say that we are the link between the industry and the education. So we look at the industry and we look what they do. So we reproduce that at the lab, educational lab, so students became more profitable once they go to the industry. So thanks again for inviting me. I'm going to talk about the reskilling and upskilling of workers, which is one of the main headaches in many of the governments and in the countries, because industry is going very fast. And the main problem many of these companies are having is that they cannot find skilled workers. So there has to be a link between the educational or the training sector and the industry. So let me go let me explain to you, first of all, what is the evolution of the teaching equipment technology. Previously, we were having traditionally manual systems. If any of you have studied technical things or engineering, you know that you were working with your hands and taking data with a notebook and taking all the information when you were doing the experiments at the university or at the college. After that, we were having the data acquisition system. Very easy. We changed some mechanical devices or electronic devices for sensors. So that was a huge revolution because we were having all the data in the computer, so it saved a lot of time. After that, Reboot were one of the first that introduced the SCADA technology in the laboratory, in the training lab. For us, it's very important that you need to use the same tools that you have in the industry. You need to use them at the laboratory so the students will learn how to work in the real world. So we are having SCADA systems, supervising, controlling, and obtaining data from a computer. So, and after that, we introduce also the PLCs. So we work in a lab, like in a real world, okay? So this was, let's say, some years ago. From 10 years now, we have been introducing a very unique technology, which is the cloud learning. With the cloud learning means that from internet, I can do the experiments and I can have the practical experiments anywhere, any place. One of the main issues that we are having during this era, this COVID era, has been that, okay, you can have online training, but it's pure theoretical. So what happens if you want to study photovoltaics? You need to see the panel. You need to see how they increase in the watts. You need to have more specific or more practical experiments. So by having the cloud learning, we can solve that problems because we will do the experiments from different places. What is the big advantage of cloud computing in the training area? That is flexible, it's 24/7, it's secure and private, it's reliable because we are controlling with centralized system, and for sure it is a reduction in cost and in time saving. Now you don't need to display yourself to do the experiments in the lab. You can do it from your house. You can do it from your cell phone or from your computer at home. So it saves a lot of money. This is more or less how it works. I have a hardware, okay, like here, and I have it in a master laboratory. And from anywhere, it can be a satellite laboratory, it can be another center, it can be a small industry. I can do the experiments and I can skill my people, or I can train my people with a very low cost and very low price. Even from another lab, at their home, the mobile phone. So this helps the sustainable goals. We have identified 9 goals that are being helped in this with this technology, as we are not generating waste. We don't use that much raw material to produce the equipment, the reduction of commute and transport, air pollution, and for sure the CO2 emissions. Some hardwares that we are having nowadays, there are many, but depending if we, for example, want to study power systems from the point of view of the utilities, or we want to study smart grid power system from the point of view of the end user. Well, as you can see, even we can combine different kind of sources of, for example, photovoltaics with wind, with geothermal. So the trainee can understand how a real system and a real electrical network works when we are combining different kind of sources. We can have a combined cycle system, let me show you, or we can have another kind of power generation. So this is the technology that we can have nowadays. Another headache, 2 headaches for the main governments, and when we visit many universities worldwide, and there are 2 main headaches that at the end the professors at the university place to us. One is the storage. There is a big problem. Okay, we generate energy, but we don't know how to store it, so we cannot have powerful storage systems. So one of the main, where the industry or the technical or the educational sector is going, is to increase that battery and storage systems. And the other one is the cybersecurity. If we are talking of Industry 4.0 or Energy 4.0, we also have to look at the cybersecurity applications, because can be a very weak point in a country if the workers are not fully prepared on these cybersecurity systems. So, as I said, any kind of power plant can be simulated, and all these can be you can train remotely from different areas. What are the benefits of the practical online education during COVID days and outside the COVID, because we think only is COVID nowadays? It's flexible, 24/7, as I said, no space constraints, no geographical constraints. I can access a hardware located in Tokyo if I want right now, so I don't need to travel there, and I can do the experiments. Unlimited number of sessions is more economical, as less units are required, because we are sharing the hardware. We need less computers, less staff, and for sure less startup cost. The investment training center has to do to have this hardware is less, because they can share the hardware and they can share the lab. So that's the important thing nowadays. It's reliable, it's more safe, as it avoids accident, and it's the confidentiality between you and the administration and the administrator, and for sure the experience of controlling a lab is totally different than using virtual training system. I always say that you can learn how to drive with a book, okay? Or you can learn how to drive by a simulator, or you can drive a car from your house with a real car in the street. Okay, so the online the cloud computer allow us to drive the car in the street, but you are from your house. So that's something that is being very beneficial for many countries, developing countries, and even for developed countries also. So thank you so much for the time. I will be at your disposal if anything you need, you want to see this technology. I can allow you control one of these hardware that we have here in Madrid. I can allow you from your place, so you can see how it works and how beneficial it is for the different countries that they have their budget are limited, but they can put the technology everywhere with a very, very, very low cost. So thank you so much for allowing me speaking today, and I can be your contact if you need anything from our side. Thank you so much. Thank you.
Thank you. Thank you very much, Miriam. Particularly for providing us with this look into the private, from the private sector into the education training area, which is very important, particularly for the manufacturing sector and for the energy. Also, we appreciate a lot on the show for the evolution of the teaching technology, how you are applying cloud computing, learning simulation to power systems, to smart grids, but also to entire industrial plants. Thank you very much. I think these concrete examples were appreciated. I will continue now with our last speaker. Yeah, our colleague Naoki will talk about a specific UNIDO actions in these areas. Thank you. Naoki, the floor is yours.
Thank you for your kind introduction, and thank you all for giving me this opportunity to present one of my projects, which is about capacity strengthening of O&Ms through IoT technology at Olkaria Geothermal Power Plant in Kenya. The project is funded by Ministry of the Economy, Trade and Industry, Japan. Our counterpart is, of course, the KenGen, the largest power company in Kenya. And also we are cooperating with JICA and, of course, Kenyan government. Regarding the O&M at the geothermal power plant, in reality, there are definitely a lot of challenges. And for example, according to our baseline study, first of all, the data is not appropriately managed. The profiling and utilization, because of that, profiling and utilization of the past O&M related incidents are not being archived. Or sometimes data storage device is malfunctioning, and this is partly led to manual data recording and entry. And some data were recorded on CD, for example, and sometimes even papers. And those are not well stored, of course. And manual data collection led to increased labor and time. And because staff members had to visit numerous sites, wells and plants in diverse geothermal complexes. And because data is not well managed, trends of aging equipment and performance degradation not tracked or managed. And thus there is basically no preventive maintenance to minimize risks, as well as to reduce costs of possible countermeasures and based on the past instances. And also there is no systematically structured O&M. For example, there is kind of lack of sharing data among sections in the company, and people use manufacturers' manuals, but those manuals are not regularly updated. And these led to not so much sharing the information or improvement of techniques or know-hows among the staffs based on the practical work. So all in all, the O&M at the power plant is weak in terms of data and human capacity, as well as planning and strategy. So I believe basically everyone agrees that ideally O&M is done to increase plant stability at its maximum capacity. In general, it is possible to improve plant operation by appropriately monitoring the condition of the plant system and equipment to detect the abnormality at an early stage as possible, and also minimizing the period of stoppage for maintenance or trip by optimizing maintenance plan and actions. And besides, it is important to note that in case of the geothermal power plant, the causes leading to the instance may vary depending on the conditions. For example, the steams or hot water, gas, humidity, and temperature. So therefore, in order to improve the plant efficiency, it is necessary to look at the various parameters of each of these individual power plants and think about the way how O&M can respond to those variations appropriately. So for that purpose, it is necessary to review and analyze the incident history, studying the potential problems in each power plant, and incorporate the countermeasures into the O&M. So therefore, it is important to have a good feedback processes among the O&M planning, implementation, review, and adjustment. So the project captures both introduction of the technologies as well as implementation of the capacity building for technical experts as well as management team. It also extends to knowledge sharing and advocacy for government officials. The introduction of the IoT technologies for O&M can contribute to improvement of the tasks. For example, profiling of problem events, performance and trend management through data accumulation, evaluation, and analysis. By appropriately profiling the incidents, the plant can avoid future occurrence of the same, mitigate damaging impacts, and suppress economic losses and increase profits. And accurate profiling is not only by preparing a record of facts, such as the direct causes of the problem, but also tracking a process of investigating and identifying root causes, as well as development of optimal solutions by applying hypothesis and verification. So moreover, it will guide future direction of the O&M, including preventive maintenance, contributing to reducing risks and long-term forced outages and reduction of the outputs. So the IoT technologies can will enable to prepare such measures at lower operational costs. However, in practice of technology transfer, time for learning, trial, and error are indispensable. And engineers should acquire knowledge and skills for appropriately utilizing and adjusting tools and techniques. Therefore, the project aims to take stepwise approach by first optimizing routine tasks and then to move more advanced applications. For example, visualizing the forecast, conducting economical O&M such as optimizing inspection interval and item selections, parts replacement timing, and so on. So based on built infrastructure and capacity, further precise predictive system for diagnosis of the plant may be considered, for example, by utilizing artificial intelligence towards future. So based, the Kengen actually has a vision of establishing a large-scale training facility, so-called Center of Excellence, in Olkaria complex, with a view to consolidating knowledge and experience of geothermal development and human resources in Kenya. And this project will certainly in line with this Kengen's objective. And this is a conceptual diagram of the technologies. The project aims to connect the sort of fragmented information and operation into centralized data-driven O&M through equipment and practice. The situation at Olkaria at this moment seems to be a little unique because there are a mix of new and old facilities, and turbines and control devices were made from different manufacturers, for example. The project will complement current activities and devices. For example, an existing cooperative data center at the plant headquarters will be integrated into a new data center, as you can see on the top. And also new measuring equipments, transfer for sending data, gateway for switching data signals, modem for sending data via network, as well as OPC servers, as necessary, will be introduced to complement the existing devices. And collection of plant data is partly utilizing the existing corporate LAN, and also as a backup, wireless system is also utilized. So as a summary and way forward, IoT technologies can definitely be a measure to address global challenges such as climate change. The geothermal IoT is one of first of its kind in the region. And the technology allows to improve O&M through remote real-time monitoring and database management, reducing costs and increasing efficiency. Data-driven O&M, the concept, may pave the way towards further advancement, such as utilization of the AI towards future. And great leap in the technological advance will only be widely accepted with trained workforce available in the region. So this is why investment in the trainings is very important, which will strengthen the local energy sector. And successful implementation of this project will unlock East Africa's potential for sustainable and reliable access to electricity, which is essential for the region's economic and industrial development. So this is all from me for now, and I'm looking forward to further discussion.
Thank you, Naoki, for this very detailed example on the geothermal power plant case, particularly for showing us the challenges that we can face when doing a specific example like this one, the optimization process by introducing IoT solutions, etc. Thank you very much. I will now start with the round of questions. Yeah, the first question will be for René. René, which cooperation approaches could be followed for facilitating the further integration of developing countries in the global development of knowledge and expertise in digitalization in the energy sector? And if you please can mention some examples.
So thank you very much for these questions. To facilitate the further integration of developing countries in this knowledge, I think the goal is the transfer of knowledge and to foster the rapid implementation of Energy 4.0 technologies. And as research institutions, we are looking especially forward to have the academic cooperation. So the cooperation agreements from universities exist in different levels. So we have international office at, in our case, at TU Wien, but also in different universities they have. And from different levels means from the student side to teach, to get their expertise in studying abroad, also in funding programs, which means in mobility grants and partner universities for longer term cooperation, as we have also seen in different presentations. And to me, one example is also because I'm involved in the IEA program, so with the Annex 18, in this case for the digital twin. And also non-OECD countries are explicitly invited to participate. And I would also encourage anyone who is interested to reach out to me or to the Secretariat of the IEA for further discussions to get here more closely. And as I know, there are also projects exist in affordable and sustainable energy systems for sub-Saharan Africa. So that focuses on improving energy management and planning, and also the clean energy transition program. So there is, I think, a lot of space for discussion further on.
Thank you, René. I will continue with the other question for Sean. Sean, the lack of technical expertise and capacity, insufficient support to overcome high initial financial and capital requirements are very often the main challenges for developing countries in their digital transformation. How can they leverage from the opportunities that digital technologies may bring to improve industrial processes?
So thank you very much for the question. It's a good question. I mean, large-scale industry in general has the funds to invest, but policy is really needed to push for decarbonization. I mean, infrastructure is needed if you want people to be producing green hydrogen with electrolysis instead of relying on natural gas. You need infrastructure for this, and that takes policy. So I think, as Naoki mentioned, there are already energy efficiency measures with IoT and AI that can be utilized. There are turnkey solutions from consulting firms that are more than happy to go and charge people to do this, but they promise that the gains that happen throughout the year in terms of energy efficiency more than pays for what it costs to do that. It's good in theory, but we'll see if that works. It's one of the reasons that IRENA and UNDP, for example, have partnered with really getting impact on the ground. We have a Project Navigator platform, which has already seen 2,000 projects. And what we try to do is get them to the bankability stage because of exactly what you mentioned, where it's very difficult because there's a lack of knowledge, there's a lack of training. And even though the project may make sense, it's difficult to actually get funding. And it's one of the things I mentioned in my presentation, the tokenization of renewable generating assets so that you can sort of spread out the investment globally. And if you use blockchain and IoT and solutions like Microsoft Azure, where the IoT device is secure and you can be ensured that what's being generated is going to you, it's all transparent. There are certain things being developed right now, but it's a good question, and there's really no real answer because it's one of the things we at IRENA are looking to sort of work on as well. But thank you for the question.
Well, thank you very much. These are the top questions, so we have selected for you, but I think that you provided a very good answer. We will continue with the next one. Yeah, Miriam, new skills sets are needed for the adoption of advanced digital technologies. How can governments support their national institutions and the business sector to reboot the learning system to skill and reskill the workforce in the energy sector?
Thank you so much for the question. It's a good question. Skilling the workers is one of the main headaches, as I said before. There are different ways or different areas. Now we have a technology that is easy for the governments to help skilling the workforce. Okay, many governments or many countries, what they have done, they have created centers of excellence. These centers of excellence are fully equipped with the latest technology, sometimes with control or remote control hardware that can be linked to any other center in the area, in the country. And also these center of excellence are the ones that train the trainers. Okay, so with the new technologies that we have nowadays in the market. Hopefully technology make us, someone explain about the infrastructure that you need to train the workforce. With the technology nowadays, this is much simple because you can have a center of excellence somewhere specialized in renewable energies, and you can allow people from remote areas control that hardware and do the experiments on that hardware. And also not only people from the remote areas, you can allow also people from small industries or workers from a small industry to upgrade or to have a practical experience in the new technologies with a very, very low cost. So by having this center of excellence, For example, we had that in Spain, and it's working because you can upgrade trainers, instructors. Sometimes the big problem is I don't have professors to teach, or I don't have someone properly trained. And also you can train the workers from many remote areas, or even a small industry that cannot afford having a lab to train their staff. Okay, so this is technology makes everything simple nowadays. Okay, so thank you so much, Alejandro. Thank you.
Thank you, Miriam. Naoki, the next question is with you. What policies and regulatory frameworks could encourage a smooth transition towards smart industrial energy in developing countries?
Thank you very much for your questions. Actually, it is again a good question, and this is why our project actually includes activities policy review and recommendation towards next year based on the experience, knowledge gains through this project implementation. So the details definitely will follow, but in general, I think I'd like to associate myself to my distinguished panelists that I believe that important element is definitely the human capacity development in this field to enhance the industrial basis and the local market in the country.
Thank you very much. I will continue with another question for René. René, how can digital manufacturing technologies help us implementing multilateral environmental objectives such as the Paris Agreement?
Thank you very much. Yes, I think these digital manufacturing technologies are fairly cheap and widely available, which, as we have seen now, because they're in development phase, and which is why they can implement comparably easily compared to total breakthrough technologies, which even takes a long-term development. And in this way, we can support countries, especially development countries, in that trajectory, which means the keyword is here, I would mean the leapfrogging, because it's then easy, the goal to build the economy in developing countries based on the renewable energy technology and not in another way. And with our research, I think we can lower the cost and increase the positive impact, especially on green technology. But of course, we have heard it already, it's not sufficient enough because then we also need the policies and so on. And yeah, this is where the UNIDO could step in with targeted programs, I think so.
Thank you very much. Sean, what is the role of digital technologies in addressing the challenges posed by intermittent energy sources?
Yes, thank you. It's a good question. This one keeps us up at night, Irina, because it's basically the question everybody asks. I would sort of flip the script in that we don't see it as a challenge, but we see it more as an asset because it's forcing us to digitize. And I think, for example, I mentioned electric vehicles, and this is something people normally see as a very challenging thing to do, to integrate, millions of cars where everyone's going to be charging at the same time. But if you use sort of smart technologies and smart charging, and there are price signals, then you can use these cars as really batteries on wheels, and they can really act as a sort of storage mechanism to increase the flexibility of systems. And it sort of is a virtuous cycle that goes hand in hand. I mean, there are a lot of examples. We have, advanced weather forecasting, for example, with AI, lets you really more precisely know how much energy will be generated at smaller time scales, and also how much will be demanded. So if there will be a hot front coming in tomorrow, that air conditioning will be coming on at a certain time. So with these tools, we really find that it's becoming easier and easier. And a lot of the barriers just have to do with convincing people that it is possible. And, one thing we've seen in Europe during the pandemic is that the share of renewables have gone higher than what anyone really thought possible this quick. And we haven't had any lights go out in Germany. We haven't had the lights go out yet. We've seen higher and higher shares of wind and solar, and it has not been a problem. So I'm quite optimistic, and I think most of us here in the office are quite optimistic, but I'd be happy to discuss further over a beer at some point, because it's a topic that we talk about a lot over here. So thank you.
Okay, thank you very much. I will convey another question for Miriam. Miriam, in order to create a more inclusive workspace within the energy sector, what actions can be taken to encourage the participation of youth and women in developing countries in the Energy 4.0 trainings?
Thank you so much for the question, Alejandro. That's the key. How we can make technology easy for everybody. What is the main problem that we have right now? For example, if you need to study PID control, the formula is like this, so it's very difficult to understand. So people are afraid of studying technical things. So the thing is that if we use the technology, if we use the computers, the tablets, the smartphones, young people will be more encouraged to go for technical things because we make things visual, so it's easier for them. And it's the same for the young ladies. I have a 5-year-old daughter, and in the school they are starting. They think they are playing with a small mouse, doing a sequence, but they are learning how to program. They are learning how to program a software, and this small mouse costs only 20 euros. So we have to introduce the STEM in the primary and secondary schools, because they don't feel afraid of the technical things once they go. They need to go to the university. So nowadays we have something very important, is that with the technology, the computers, the tablets, the iPads, young people, they don't feel that afraid of understanding the technical concept. So if you introduce from a very early age this kind of concept, like if they were playing, they will become engineers, or they will become workers in the energy sector. So making it simple, that's the answer, making it simple. And nowadays we have a technology that make that simple. Okay, so thank you.
Okay, thank you. I think also this should be boosted by the policy, frameworks, and also on the education programs, etc. Thank you very much, Miriam, for this. I will ask one question to Naoki. The project at Olkaria Geothermal Power Station in Kenya that you explained it to us is a prime example of North-South cooperation in the renewable energy field. How can we leverage greater North-South triangular cooperation in this sector, and what are the primary benefits?
Yep, thank you very much again for your good questions. And as I mentioned in my presentation, the Kenyan has a vision to establish a so-called Center of Excellence at the Olkaria Geothermal Complex. And as you know, geothermal resources in East African countries are enormous. And the countries around are actually interested in utilizing these energy resources. And that's why this project may have a horizontal dissemination impact. Good practice may be transferred to the other countries. And the data-driven O&M through IoT technologies definitely is not for only the geothermal power plant, but also, of course, the other type of renewable power plants, as well as other type of industries that is applicable. Technology can be applicable to those, and exponential sort of impacts can be accrued if the concept of data-driven O&M is being applied for those industries or other type of power plants. So we have a good expectation of this horizontal knowledge dissemination effect towards future by doing this project.
Okay, thank you very much, Naoki. I have a challenge for all of you. I took a question from the floor, and I will ask all of you this question, and I would like to have a short answer from your side. In short, what do you think? What could be your main idea to answer this one? Yeah. The question in particular is this one. Within the decade of action, yeah, we will be able to flip the pie chart showing the use of fossil fuel versus renewable energy by 2030. What needs to be done to make this flip happen? Yeah, particularly within the context of the climate change and the fourth industrial revolution. So I will start with René. If you can give me.
Sure. Thank you very much. Short answer from my side. I think it's different situations and different questions to answer. One possibility could be the coupling of the sectors and use the possibility of all energy carriers and support these perspectives with breakthrough technologies and the possible of digitalization. So it's broadly spoken, but I think it needs more time to go in detail.
Okay. Sean?
Yes, it's a broad question. I think, just very quickly, I think the power sector will take care of itself. I think industry is really what will be difficult, and I think it's mainly these 7 specific sectors that we identified. So iron and steel, cement, chemicals, aluminum, road freight, aviation, and shipping. And for those, the main options we see are electrification, direct use of renewables, heat and biomass, indirect use of renewables, so producing green hydrogen. And then we need to also rely on carbon capture and storage. And we need to really reduce demand with energy efficiency. So I think those are the main sort of mitigation options, and those are the main areas where this really needs to happen. Otherwise, we're going to find ourselves in 2030, 2050 with a lot of emissions still coming from industry and no real way to decarbonize unless we really plan ahead with the infrastructure now. So I wouldn't worry so much about the power sector, but I would think more about that for the long term.
Okay, thank you. Miriam, I think education and training will play also a major role here.
Yeah.
Give us your comments.
Yeah, and not only education and training, also research. I've talked to many universities worldwide, and one of the main problems that we have right now is that fossil fuel energies are inexpensive, or at least they are less expensive than the renewable energies. So the thing is that by the time it's been the research of these universities are going more and more on how to make these renewable energies more inexpensive, then we will have a solution to change a little bit the fossil fuel for renewables. So it's been, I said to you that I'm talking to many universities worldwide, and it's one of the main type of research they are doing right now, and also in the European Union, research in renewable energy. So that will happen. Okay, we will change the renewable for the fossil fuel for renewable for sure.
Thank you very much. Naoki.
Yes, thank you. So yeah, I think definitely we need much more bigger investment, and basically investment is done to maximize the benefits, and there are sort of short-term foreseeable benefits, and there are longer-term benefits if you look at the global benefits, for example. And definitely to realize the investment finance is a key. So basically to make that kind of enormous investment towards renewable or to reduce the global emissions, we definitely need to have so-called transformational change that include the people's choice, the way of thinking, the way they live, or almost entirely everything. Otherwise, the finance itself wouldn't change, I believe.
Thank you very much. It's very nice that all of you has touched the different angles of this question, particularly highlighting investment, education, research, technology, political framework, wills. Yeah, this is I think it's very nice that we have all of you. We want to really appreciate all your support for participating in this webinar. I think we all have enjoyed it a lot. Thank you very much for all the knowledge that you have shared to all of us. I will like to remind all of the colleagues that are attending to this session that we will make the presentation available for the reference. Also, the questions posted in the chat will be addressed, if not in this session, but we will send you later on a reply answer in short time. If you have any inquiry, additional question, etc., you can send it to us, and we will try to convey that one to the panelists. I will also like to take the opportunity to invite all of you to attend the next webinar planned for 11th of December. This one will be talking about a new initiative between UNIDO and the Vienna University Innovation Lab. With that, I think we are ready to close the session. We thank you very much again, our distinguished panelists, and for being here with us today. And we look forward to working with all of you to implement our digital transformation strategy. Thank you very much. I wish you all the best.